Good morning, everybody. We have a wonderful guest this week on Hackster Café, our weekly show at 10 a.m. every Tuesday, 10 a.m. Pacific every Tuesday this time. And so we do interviews with cool people who are doing awesome stuff with technology. Today we have Prosh Mix, who I saw first on Twitter as someone who creates these amazing time-lapse 3D printed music videos, and then I dug into your LinkedIn a little bit and found some other really fascinating stuff that you've been doing with brain-computer interfaces. So I think there's a ton of really fascinating stuff to explore here. But you're also famous on TikTok for doing these time-lapse music videos. So can you tell us a little bit about what you do, and we'll dig into things from there.
Yeah, for sure. I think famous is probably pushing it a little bit, but
1,000 people.
yeah, no, it's quite crazy. Actually, if you go down, when I hit 10K followers, I made I actually did a 3D print with 10,000 points on it just to try and visualize what it is, because it blew my mind, to be honest. And I mean, that's not even talking about like the millions of followers that other people have, but I really wanted to get a visual of what that really meant. It looks like it was quite a long time ago, but yeah,
Oh, here we go.
There it is. But it's kind of hard these days in social media to really understand and think about like the number of people that are actually watching your videos or looking at it. And I'm super grateful to TikTok, really, because it's easy to get your sort of content out like that through TikTok. So people in the 3D printing community, people who love art, people who like time lapse and videography in general, sort of all have come together somewhat to see these things. So I think the way I originally had sort of started out was some very simple time lapses when just of normal 3D prints. Like there are many 3D printers out there, creators who do. So it's taking one image at every layer of the print. So say if you have I don't know, a 20, see if I can do the maths, like a 20 millimeter tall model, and it's in 0.2, I can't do the maths, it's like 100 layers tall or whatever, right? So if you take 100 images, so you have 100 frames of video, basically, when you put it all together, it's like a stop motion / time lapse. And I figured when I was doing just normal models of everyday things, that actually this is kind of like a stop motion time lapse, and I could put in content which changed throughout the print. And if I did that, you then create an animation. And that's what I did fairly early on, trying some experimentation with it. And what I found was I did some really simple ones, some of my very early TikTok videos, which is just like a heart with an arrow going through it, for example, which was really, really early on. And then there was a simple, I thought Valentine's Day was coming up. This was actually both for Valentine's Day. I happened to start around that time. And I figured that it might be nice for people to send a TikTok that was sort of just saying, "Be my Valentine." So within the print, as it went through, there we go.
Got TikTok to work now. We can look at
it. So really, really simple sorts of things. The reason why I put it within the heart as well is because if you know about 3D printing and 3D and designing for it as you're slicing through, each layer that you have above needs to sort of have layers underneath for it to build on top of. So you can't create certain shapes that just come out of nowhere. You need to either have like an angle that goes up to it so that it's supported, or create supports. And I didn't want to have any supports within my prints because they are, exclusively there as an artistic piece and not an actual functional piece, which you can remove the supports afterwards and use for something else. So I decided to put it fully in a shape. And what that means is the actual internal support structure, like these concentric circles that you see in this print, basically holds every other layer up. And it's sort of then seamless to some degree. And it hides really the fact that with 3D printing, you do actually need these support structures. So yeah, I kind of moved on to things like this. This is a music video. So these are the lyrics that you're seeing on the screen.
Yeah, I'm trying to see if we can get the audio up, but it's being... Oh, there we go, finally.
Yeah. Maybe the
so
audio is
cool.
going through. I can't quite hear here, but yeah.
Let's try this. Is that coming through now?
Yes, yeah.
Awesome.
So this is a song that one of my creator friends, he had heard this music, or somebody had reached out to him, and he instantly loved the song, and he said, oh, you know what, I know the person that might be able to do something with it, sent it over to me. And actually it was, for this kind of project, was quite a quick turnaround. I happened to have the weekend free, and I listened to the song on Friday afternoon, evening. I'd started modeling it then, I think on the Saturday morning, actually. And by Sunday afternoon or evening, it was done. And that's 3 different prints. I think 1 or 2 of them were about 10 to 8 hour prints. And then there was another one which was about 7 hours. So I was sort of designed the first one, printed it. While it was printing and doing the time lapse, I was designing the next print. And I kept doing that until the whole project was done. And luckily, I didn't have to redo the prints too many times. It was like 1 or 2 iterations for maybe one of them. And I was really pleased that I was able to turn that out relatively quickly. And yeah, I don't think anyone else has made a 3D printed time-lapse music video before. So first for that.
Have you seen other people sort of adopting the genre since you started becoming popular with these?
There have been a few, yeah. Friends, really, actually. Other creators on TikTok, other makers who've reached out to me as well and said, "Hey, I'm trying to do this. I'm not sure what the best way to do it is, because there's sort of a lot of parameters to play with, which I've been playing with since, well, for a couple of years now, actually, since I've started doing it. I think the first one that I did was, this might take a lot of scrolling to go down, but is a time lapse that went from 2020 to 2021, I think was the year. So you can see as it goes through the print. So this was a bit of an explainer video as well, which shows the process of how the design goes.
About that.
Yeah, is how it's sliced and then how it's printed. And then, of course, this is the setup that I have with the camera. It's a little bit modified since then. I've added some lights and things to keep it dynamic. And there's a lot of sort of, you can see the sort of stray lines coming out at the top there, which is purely because every time you take a photo, the print head moves out the way. And when it moves out, if your settings with the filament isn't quite right, in that case, I think it was there's a very old filament that I was using. So you got the little lines, which in the end I quite liked, because it sort of looks a bit like fireworks, which fits the 2020.
That's a really nice way of putting it.
Yeah. So I kept it in. It's sort of a accidental thing that I quite enjoyed, but yeah, it's been really fun. You know, just doing a lot of them that are sort of sporadic, random ideas, but something like when the song came up, or the Vecna model, when I created that for Stranger Things, that was one that seemed really obvious to me at the time. So I can show you here.
Ooh.
This is the Vecna model. This is actually one that failed mid-print, and you can see the text just there. Maybe I can make it a bit bigger and clearer for you.
Oh, nice.
So you can see right there, it says, be running up this hill. The Vecna model is a beautiful model that was modeled by somebody called 3D-Sculpts. His name is Wayne. He's on Twitter, and you can find links to him through my videos and things like that. But essentially, yeah, he created this amazing model. I thought, okay, I should put the audio and the lyrics to Running Up That Hill, which was trending at the time on TikTok as well. And it sort of just made sense as a little fun time lapse.
Hopefully they won't block our video for these things, but and you've credited here the creator of the model, 3D-Sculpts.
Yes, yeah.
Incredible. So this is one that worked out in the end.
Yes, yeah, that was one of the models that worked. I played around with it a lot. It was, as you can see, like I think, like you mentioned, the actual print is a lot smaller than what you might think.
So it looks so epic in the video.
Yes, yeah. There's a lot of well, the camera setup that I have for that is, the camera's really close to the build plate, and you cut out a lot of the build plate actually for the vertical format. So yeah, you get this sort of imagery coming through, and that's one that I really liked. Very happy with that.
It's beautiful. And you've mentioned a couple of times now this how you had issues in the print that you feel like came through sort of creatively as a way to almost augment it, like with the stringing in the 2020 21 what 2020 2021 one, and
Yeah.
also the issue with the Vecna model. And I noticed that your username used to be wabi-sabi.3D, and that seems to,
Yes.
yeah, would you like to tell us about that?
Yeah, I mean, yeah, when I started, I'm assuming from the way that you mentioned that you know what wabi-sabi means. So for me, it was the perfect username for 3D printing content, because wabi-sabi is the principle of seeing perfection and imperfection, or
Mm.
there's many sort of offshoots or things around this Japanese philosophy, where either through aging or time, things change in, like patina that you get on metal,
Mm.
or on leather, or anything really. The idea is that that time is making, or has a process over that particular material, and what it ends up being has new and different value, and seeing actually the beauty in that perfection is a philosophical, way of thinking about it, which I thought made perfect sense with 3D printing, because you do have a lot of failures, you do have a lot of these things that come through, and one like the 2020 2021 tree sort of thing coming out of it was one of those things. I maybe you might not appreciate it when you're trying to print something and you're like, oh, I modeled this thing, and it's got all these strings and various artifacts on it, and that's not right. But I like it. It's part of the process. It's part of the learning. You might make another one after that to solve that problem. But like, even in its particular, I love this model. This is one of my favorite ones. It's the one that failed, and it failed in such a great way because it failed right here, and you can see the text. Like, none of the other models you can see the text in.
Oh.
They are just full models, and there's kind of a beauty in that, in the art in itself, which I really enjoy. That once it is printed, and once the time lapse, once every photo at every layer is taken, you will never see that message again, other than through the video. So, if you can imagine a sculpture that's been put up somewhere, either in an art exhibition, or maybe it's a sculpture that's publicly available, publicly mounted in the street, or something like that. You don't really know what's inside it. You don't know the story, and there could be hidden, story within it, a hidden meaning, or something to it. And I quite like that as part of the time lapses which I create, where the only way you can access it is through that time lapse. And yeah, I think it's an
Kind of
interesting
a
concept.
similar idea with your one here, where you have to apply a light in order to see the hidden text inside, which I love.
Yes, yeah. I mean, to start with, I really wanted something that was that looked blank. So I wanted to create some piece of artwork that would go on your desk or on the wall, and be hung up, that looks completely flat, completely plain. There's
Mm.
nothing to it. It's just one color, white or whatever. Then you switch it on, and you suddenly have the message appear behind it. I don't know why
It's very
that
magical.
concept sort of appealed to me, but yeah, that was something that I quite enjoyed.
Would you, from your background, often we have people coming out, or if you compare with mine, for example, stuff everywhere. And sometimes when we have people come on, they have their own like nerd setup in the background and stuff. But yours is this beautiful, like, two sources of light, I believe. I don't know, so maybe a white one in the front, but anyway, you've got like this dual color thing going on like you do in your videos too, and it's kind of minimal, and it kind of reminds me of some of your art, and this piece as well, where it's like it's smooth on the surface, and you can, and it's very, it's not like perfect. It's got some wabi-sabi in there, but like also it's sort of seems like a featureless object until like it's got these hidden things inside of it, and it seems to tie in with a bit of a minimal aesthetic for me. I don't know.
Yeah, I try to keep that theme going to some degree. Like it's somewhat conscious, but it's also natural. I think in terms of the aesthetic, I try to keep things minimal in general through my engineering work that I do actually at work, or even if it's things that I make around the house, or with the artwork, especially. Clean, simple design is often tricky to pull off, and there's a lot to say about that, and I aspire to it, so I try to keep it clean and keep it minimal where possible. Simple lighting and things like that actually go a long way for the time lapses. It's actually really tricky to set up the time. I think the first time lapse that I did looked really, what's the right word? It looked like somebody had just sort of filmed it with their phone, maybe, or like, it didn't have any depth to it. It was very amateur looking. And I quickly realized that with a few little tweaks of the lighting to get that shadow, to emphasize the text and the word, like that one in particular that's playing now on the screen, I did some initial prints of that, I think with just a white light with a gray filament, and it looked so bad, basically. It had no depth to it. It wasn't worth looking at, basically. So it's really amazing how I know any videographer would tell you this. I'm not a videographer by any means, but like just a few simple tricks with lighting will take your footage from so far.
Is it what tips would you give?
Good question. I experiment a lot. So with these shots, for example, I did an initial one. It had just the very basic lighting. I changed the lighting up a lot, took test shots, individual images. Unfortunately, there's nothing amazing that I can tell you like, oh yeah, this is the secret behind doing this sort of thing. It really was just, I didn't even use any principles. It was just, okay, one thing that I thought about was shadows. So I want to use shadows to my advantage in this print. If I had too much direct light from the top, it would have lit the earlier parts of the print underneath. And therefore the very most top layer, which is the bit you should be reading, would be less visible because you would be constant. So you can see that the text fades away in the background as it goes out. And that's because the lighting is set on either side. And so there's not really much light that goes directionally, like vertically down into the print that lights up the shadows. So those shadows allow it to just fade away into the background. Whereas the initial ones that I did were very flat looking. So you could see like bottom layers of the text really clearly as it went up. It was obviously less bright, but not to the extent of this one. So angling the lights was a huge difference in this one.
Cool. And do you use any special kinds of filaments, or?
Not particularly. I mean, I have my go-to ones, like the ones that I'm used to. I think everybody has their go-to filament where they're like, I want to print something and I want to make sure that it definitely comes out right. And they have filaments for that. So I have a couple that I go to. I found the Polyterra, Polymaker Polyterra PLA being very good for that for me. I use my Prusa, and the default settings just work. There's nothing special going on. I really just use default settings most of the time.
Cool.
I think I would say that just practice and making sure that gets dependable is really useful. I've experimented with some other sort of dual color filaments and things like that, the co-extrusion stuff, which is nice. It's fun, but it's not simple, because I tried the Vecna model actually with it, and the silky effect with the dual color that's actually in it, even when I used a white light, there's a lot going on with it. So As you can see, like the Vecna that I printed was in a dark gray color because it picks up the light really nicely. Like if you put a nice strong, I have a lot of purples and pinks and oranges in my time lapses in general, and it really picks up that color. So I think one of the comments that I got on this video was, which I responded with the video, was what color is the filament, because it kind of looks like it could be a two-tone one, but it is very exact, and it is definitely in the lighting. Or people thought it was purple with an orange light, which is very fair, but actually is just plain flat
movie
gray.
magic.
Exactly.
Oh, what you're doing is so magical. I have so many questions. Let's see. We've got a question here about your process, so we might as well start with that before we jump. I do want to get to your fascinating other biomedical side, but first up, if you wouldn't mind giving us just like a really quick overview of what you're using, because I know that you've said that you're using, or you tag octolapse on your prints, on your videos. And,
yes. So I do use octolapse for all of them, basically. What I did, I spent back when I first made my first time lapse, I'd set up octolapse with a webcam because it's very, very straightforward to do, or at least it was for me on the Prusa. And I had a Pi Zero plugged into the back of it, so there are instructions that Prusa give to you that, because it goes directly into the you have to excuse, I'm like, my electronics background is not particularly great. I appreciate and work with electronics and electronic engineers all the time, but yeah, it's definitely not my forte. But the actual board on the I think it's the INC, if that's how you pronounce it, board that powers the Prusa, the Pi Zero goes directly in with its pinouts into the back of it, and then it can control the actual Prusa. So that's what I was using. I then tried to use my camera. It didn't work originally. I've got a Canon DSLR that I use with it, which is plugged in via USB to the Raspberry Pi. There's also something called Octolapse with Octoprint, and Octolapse allows you to then make those time lapses with and interface with a camera using the G Photo library, the G Photo 2 library. And I basically went through all of the tutorials. It's probably a very standard setup that everyone does first time. It took me a few times to get it. But once I got it working, as long as I hadn't messed up any settings, it worked every single time. And that kind of reliability, when you're doing like prints that are X number of hours, is, you know, is critical, basically. So that's why I use Octolapse, and because it works for me, I haven't really thought about it. I haven't considered oh, sorry, that's if you haven't, have you considered automating? Yeah, of course, it's automated. I wouldn't be able to do it any other way. I think the other way that I've seen is a sort of small switch that you have on the side in G-code after every line that moves the head over to the switch to click the button, which also, yeah, works really well for those creators who use it. The nice thing about Octolapse is that you can set the position of the print head wherever you want in relation to the print as it prints. So all of mine that I've published, they all go to the back of the bed and they're out the way, and you just see the head maybe in the background rising up and out the way. But what you can do is you can have animations like a spiraling animation as it goes up, or you could have one that goes. Sorry.
Oh, I was sort of talking to myself. I was there's this example one, and I'm wondering if they did. Nope, they have it be invisible here. But you know, if you're doing a vase or something, you could have it do like the spiral thing, and like,
yeah, or you could have one that goes back and forth, which is really trippy. It sort of goes back and forth and goes up the print, which is quite interesting. But again, for me, in these time lapses that I put up, the focus of it, the focus that I wanted to be on is the actual message and the whatever's in the print. A lot of people don't realize it's 3D printed though, which so I've got like comments saying, or like people have told me, yeah, you should, because it's not obvious. It looks like it could be VFX, or it could be lots of different things. In fact, when I posted the Vecna model, I had it, so a couple of my creator friends, or quite a few of them, had reposted the video, and in their comments sections in two different creators, where they have millions of followers, they had said in the people had said in the comments, they were sort of mocking other people, saying, "Oh, well, it's obviously CGI. You can see where, you know, it disappears in the background and stuff like
you can
that."
tell because
Which
of the pixels.
yes, yeah, exactly. Or they're saying like, "Oh, you can see it fades out," like how I mentioned the text fading out in the music video, and I just find it so funny because they're so adamant that like it's obviously not real, which I found, yeah, insanely. Well, it was just very, very funny. But I like the discussion. It was interesting. I didn't even say anything about it, to be honest, because it's quite nice to hear the discussions and see what they say. And I almost wanted to say, "Yep, you got me. I'm a VFX artist, and that's what I do."
It seems so clear though when you look at these. There's a couple times we've kind of come back to this idea of reality, and you know, the idea of wabi-sabi being that like it really shows the beauty of the wear and tear of reality, but also like, you know, with these things, often with 3D models in CGI, you're really just seeing the surface. If you look at a game model or something like that, it's hollow on the inside, and you're kind of
Yeah.
really playing with that, and making it so that it's almost more real than other 3D printed things because there's like information on the inside. I don't know. There's something there in my head that's hard to express, but I'm also possibly just ripping off exactly what your point is. But
No,
yeah,
I think it's
reality.
that's a very good point. Like, it has another depth to it. It has another meaning. There's something else
Mm,
going on inside it. I like that, and having that hidden layer beneath it is,
mm,
it's interesting to me. I don't want to be too cheesy about it, but it's almost on the level of don't judge a book by its cover to some degree,
mm,
in that there's more to what you're looking at face value, because you haven't seen all the experience of that particular thing, like when you meet people or whatever it is, you know, there's like their appearance or whatever you see on the outset, there's definitely a story behind, you know, everything. So like, you know, to not be too cheesy, like not
mm.
judging, you know, everything by its cover is something that I believe in, and I quite like that hidden value to the message too.
That's wonderful. Um, I would love to ask about some of the biomedical stuff that you've done. So, uh, I first noticed on your bio that you've created a brain-computer interfaces meetup at South by Southwest one year. But also through talking to you, it turns out that you currently work on a brain-computer interface company, or you work at one. And what are you doing there? And obviously you can't tell us too much because it is a company. But yeah, in broad strokes, and what brought you to brain-computer interfaces?
Okay, so what brought me to it was, actually I was working in a makerspace at my university, which I was studying at, which was a fantastic place to learn all of these sorts of maker activities, and I became a member supervisor there. I was working there for a while, whilst I was graduating, and once I finished, I was there was a biomedical startup called Labs within UCL where I was studying, and they needed somebody to build their
Mm.
brain imaging system. So, as a very fresh young engineer, I went over and started working on the mechanical design and also a bit of the manufacturing and you know, developing the systems, which weren't being made at any volume prior to me joining. And the reason why they brought me on was to get these systems out the door. So in doing that, it was an optical based system. I learned very quickly that I quite liked optics. It's a very challenging field and very interesting. So I learned and got a bit more interested in that. And so essentially the brain imaging systems that we were using use near-infrared light to measure the oxygenated and deoxygenated blood that's flowing through your brain. So
I just saw someone, and I mean, I know this is something they've been doing for ages, but I just saw a new device. It's a TechCrunch Disrupt that's using the same system to detect blood flow. And in the past, I've only seen, with most hobbyist devices, it seems to be a current, a power flow system that they're measuring. But infrared is so interesting.
I mean, the principle has been around for a while and is actually very widely used. If you've ever had one of those things that clip on your finger in the hospital, that pulse oximeter is essentially the exact technology that I'm talking about. It measures the amount of oxygenated, deoxygenated blood, and also your percentage by comparison as well.
But you can tell what's going on through the skull using this? That's still incredible to me.
Yeah. So there's a lot of research that's been done into this. The technology is there's many different types of technology, but is diffuse optical tomography. So that's using light in order to measure these things. FNIRS is one subsect of that, which is the first company that I work for, Labs, was making an FNIRS-based device, which is functional near-infrared spectroscopy. So that's essentially the same thing, but using, putting it on the head and getting functional activity or functional information out to then, if you have multiple sensors on the head, all over the head, you can see you can broadly, understand. Actually, funnily enough, that photo on Wikipedia in the top corner there is a photo that I took whilst I was working at Labs. That was the system that that I've built, and I did this photo session with one of my friends who's modeling there, which was good, and all taken within the Institute of Making, which is the place where I was working just before that. So yeah, Wikipedia stealing my photos. No. But yeah, that's sort of the basis of or sort of some of the technology. There's many devices that have come out of that. And then when you look at all the smart trackers that you have, all the watches, all the Fitbits, things like these smart watches and things like that, they all have if I take it off for a second, the flashing light on the back. And what that is doing is essentially the same thing again. It's looking at
cardio watch from Chaos.
Ooh, there we go.
They've got the conductivity based one, and then also the little flashing light guy.
Very nice. So you know exactly what I'm talking about.
But it's still cool to hear you explain it.
Oh yeah, I mean, I'm fascinated by the technology. I think it's brilliant. I understand it to the degree that I've been working on it, but it still blows my mind every time we discuss it. And I work with some very, very, very intelligent people that would be able to explain this and talk about this way better than I can. But to be around that and see the development is actually really interesting and really fun. And it's one of the perks of being involved in engineering, to be honest.
For the record, I didn't. I still didn't quite understand how you get it through your finger. I can understand, but through your skull is still incredible to me. So I'm not pretending to that I don't know that to get you to explain.
No, okay, so
legit question.
No, okay, so to go back to your question, sorry. One thing that I actually didn't really think about or consider until fairly recently, which is almost embarrassing because I've been working along this side of things for a while, is that we always see a skull, especially the human skulls that you see, as a hard, dried object outside of the body. But when it's in us, it is living tissue, and it is hard, don't get me wrong, we all know that, but it has blood flow to it. It's a lot, the actual composition of it while it's in our body is different to how it is outside once it's calcified and dried out completely. So you can imagine that light can still pass through, it's more transparent than it is when you see it outside. Also, when you're using near infrared light, I guess it's not as much on the visible spectrum, it's more towards the infrared. So you get more penetration, but equally, with systems like this, you've got very, very sensitive detectors picking up, not much light at all, because you're putting like as much light as you can in, and then it goes in through the brain, it scatters and moves around, and then it comes out again, and you're only taking a very small amount of that light back out. But through that, you can do a comparative measurement, and therefore assume or deduce, what's happening with the blood in the brain.
That is so cool.
There's lots of clever stuff that's going on in there for sure. But like on the very basis of it, I like that's how it is.
Thank you.
No worries.
So yeah, would you like to tell us what you're up to these days?
Yeah. So as you mentioned, so I'm working for a startup. It's called CoMind, and what we're currently developing is it's not yet out. It's not released. It's very much so in development. So there's not a huge amount of information. Maybe soon-ish, I don't know. Some more communication will come out on that. But essentially, the vision or the mission is to create neurotechnology that will benefit us all in some way. So creating that link with us and the brain, there's so much going on in there. There's so much untapped resource and information that we can know or we can learn about ourselves that we've been building on for a very long time. And we've come to a point now where we have amazing compute and amazing machine learning and algorithms and all of these wonderful things, plus optics and technology that can all come together and potentially push this, that lots of different companies are working on taking that information from the brain so we can do great things with it. Hopefully, there are so many applications of it. It's endless. But my particular role is involved in the mechanical. I'm a mechanical engineer by trade, or optomechanical. So I worked with the optics and the mechanics, and that's where my contribution is in the company.
Cool. Now I wrote down a question before because I didn't realize before this that you worked for a company doing this stuff, and this is a question I'd ask you anyway. But I noticed that on their page they have a specific section and a specific page that calls out users owning their data and security and things like that. And this is like one of my top questions that I would ask anyone building something in biomedical, the biomedical sphere. Could you tell us a bit about your own thoughts on security and what kinds of measures are needed, what the best practices are that you use or that people at your company use to keep people safe with this stuff?
Yeah, for sure. I think this is all my take on things, rather than from the company side.
Totally.
The information on the website there, I think, covers most of it. But from my side, my take on it, I actually, when I went to South by Southwest to discuss the brain-computer interface stuff in that meetup that you showed previously, I was lucky enough to speak to Mary Lou Jepson, who is the founder of a company called Open Water that's also working on a brain-computer interface technology. And she had founded the company at the time, and she gave a talk on how you could use it to telepathically communicate, which was super interesting. And she had I had a lot of questions on the ethics, and I proposed them to her, and we had this really great sort of roundtable discussion with a few people who were all interested in the ethics and interested in open water and things. And what we basically came out from the conversation is we need to keep a close eye on this, but right now it's sort of up to the developers and creators to think about these things and establish it, which is interesting and is a bit scary when you think about it. But I think, like CoMind says in its literature, being open and clear about these things and making sure people have the right to their, owning their own data is so important. We all know this more than ever, and will be a theme going forward. And bringing that back, because it feels like in the initial stages of social media, maybe we lost some of that to some degree, and we're really like now trying to bring it all back. Every company, Apple, Google, like we're all trying to give ownership over that data again, and it'll definitely be, I think, a requirement in the future for all of these companies.
Yeah, and I feel like those big companies that you're mentioning often are doing it in a sort of reactive way, like, Facebook, Google, etc. They're sort of like doing it because there's been this pressure from the community, and it's a little, you're not necessarily sure if they're like really doing it, or are they just like sort of
Yeah.
putting a veneer of like privacy on the top of it for sort of PR reasons. So it's really comforting to see a company like this taking a very proactive approach and being like, yes, you own your data, you have control over it. And that feels like something that has to be baked in almost from the start, because I've seen companies where they're like, we'd love to provide people their data, but we can't because like we'd have to build a whole thing for it and make sure it's a good experience and stuff. Do you have any insight into the challenges involved in that, or how they're addressing them? Or I know that you're on the hardware side, so no worries if not.
Yeah, not particularly actually. It's quite early days, I think, probably for that. But it is something that is discussed, and it's like utmost priority, of course. So it will be built in from the beginning, I'm sure, for companies like CoMind and anyone else who's doing it. I think it's actually a really good. It's a really good key point that might even be a disruptor for certain companies when compared to other existing technologies, like you said, because it's more difficult for, even from a trust perspective, for a consumer. Like, if you already don't trust a big social media company or something like that, when they come out with a device which is more intrusive, it's really hard to gain that trust back, in my opinion, I think. I'm sure there are lots of different methods that you could try and do that. But when a new company comes in that's like, as their core principles and values, that we are open, and we give all of the ownership of this data and everything to you, that is a different story that you're now telling. And the focus is different and the value is different. And I think that is quite a strong selling point for any newcomer to the market.
Yeah. I'm curious. I also found out that you worked on a cool sterile gestural interface for dentists to
Sure.
interact with X-rays, and I'd like to ask you about that. But also, like, are there other it's not just brain-computer interfaces for you. You've worked on a lot of different things, and I'm
Mhm.
curious what you're most excited about right now in the field of biomedical technology, like things that are just coming
Ooh,
out.
that's a very good question, actually. I might need to think about that one. There are a lot of interesting things on even the brain-computer interface side of things. I think there is a project or product called I never know how to pronounce this, so apologies if I pronounce this wrong, but it might be Galia or Galia, sure, which is a collaboration between a company called OpenBCI and I can't remember who's doing the virtual reality side of things, but it's basically an integration of um, EEG and there we go, and virtual reality, then giving you another method of input through the brain signal, however you want to look at it. And there are some interesting implementations where you can take very fundamental brain signal that is quite easy to take out of an EEG signal and interpret that in a certain way such that you can add extra functionality to games. I think it's in some of the some of the videos that they have of demos. So that's one that it seems really good, because I love at my very core, I love the application of technology. So for me, the last role that I worked on prior to what I'm doing at CoMind was working at a company called AdLens, where we were working on virtual reality headsets and the optics behind the virtual reality headsets, and making them more natural, more and for augmented reality as well, actually, making it a more natural viewing experience. So one of the problems that you have with virtual reality in terms of how it works with your eyes and if it's natural or not, is that when you put a headset on, you've got lenses. There we go. This is actually the product that's come out here. Actually, the Virgin's accommodation is exactly what I'm talking about. So that's up there. But the way this works is a virtual reality headset has a screen that is in front of you and two lenses that are right in front of that, right? So the lenses help you focus on the screen. And what it actually does is it pushes that screen out to a distance that is basically far distance. So it's usually about 1.5 to 2 meters away. So your eyes, when they're focusing on the image, they're actually focusing on something that is 2 meters away, not something that is right in front of your face. So when you have this three-dimensional effect of, like, I don't know, a fish swimming past your face or something like that, and it's coming quite close to you, and you start to now focus on this point that is here rather than something that is 2 meters away, your eyes, because of the way that 3D works, is the two images that are next to each other are positioned in a way that your eyes have to go in, right? So when they go in, that tells your brain that this thing is right in front of you. But the lens in your eye is still focused 2 meters in front of you. So there is a disconnect between the focus of the lens in your eye and the position of the convergence of your eyes.
Wow.
And that difference is called the divergence accommodation conflict, which is what is written up on that web page. And you don't get this naturally in nature, because if something is 2 meters away from you, it's 2 meters away from you. So they both link up. So the way your eyes work in normal life is if I looked at something 2 meters away and then looked at something close up, when my eyes converge to look at that thing close up, it tells the muscle in the muscle contracting the lens to start moving, because it knows it needs to get there. When it starts moving, there's a feedback loop in your brain that goes, wait a minute, this is suddenly blurry now. And it breaks the link between your eye convergence and the actual focus of the lens inside your eye. When that breaks, the theory is that it can lead to sickness. So a lot of this, like 15-20 minute motion sickness effect that you get from virtual reality could be linked to the divergence accommodation conflict. And that was a project that I was working on, in creating this huge rig that you put your head inside. It's got little lenses that move in and out, which changes the focus depending on where you're looking. So if you were looking up close, the lenses change. And in those lenses changing, it means that your eye then also changes. So it's bringing back the link between the divergence and the accommodation. And the accommodation, which is the focusing of the eye.
That is so cool. Thank you so much for giving that whole explanation.
No, yeah, I loved that project that I was working on. It's such an interesting project, and it's something that we will work towards, and you will see solutions for this in the future. I'm sure. Currently, I haven't really seen anything on the market. I'm really keen to see how that works out. But there are different ways in which you can introduce this, the requirement to accommodate to see things there as well. And yeah, it's a fascinating problem. It's especially an issue in augmented reality, actually, because if you can imagine the same situation, but now you can actually see things in real life. So say you're driving down the road, and is this a good example? Maybe this isn't a good example, but say for example, you're looking around, you have an object that's near you, and next to that object, you want to say what that object is with your augmented reality screen, with the extra information you're putting on top of it. If you're looking at that object and it's right next to you here, but the actual screen that's projecting the information next to it saying this thing is a 3D print, if that is 2 meters away, then you're focusing on something that's really close to you. And then to read the text next to it, you have to focus on something that's really far away. And it breaks the seamless sort of nature that the augmented reality interface should give you, which is that everything is in the same plane and next to each other. And then you look at something over there in the distance, and that's all next to each other as well. So throwing the focus of that image into different places, and having the depth of field, because sometimes maybe you want that thing that's in front of you out of focus because you're looking at something in the distance, and that gives you that extra layer. If everything was always in focus, which is another optical approach as to trying to solve the problem, using things like I think it's a light field based technology where the light that's going into your eye is basically, it's like a laser image, so it's always focusing on your retina. That means that you lose that depth of field, that things look blurry when they're not supposed to be in focus. So matching the augmented reality with the real life image is another problem, which you might need either. Well, there are many solutions to it, including liquid crystal sort of technology that has multiple layers, and each layer is a different depth, and you can sort of merge those layers together and you create a 3D image. And there's light field imaging where you get like things are actually coming at you from the distance that they should be. And then there's lenses that change and move, like the ones that I mentioned, through various technologies as well.
It makes me want to ask these Tilt 5 people how they do it. They have little, I'm not sure if you've seen this, but it's little head-mounted laser projectors that are pointing at a retroreflective screen, so each person gets their own view that's sort of lasered back at them with perfect focus. But also, everyone who's making cyberpunk stuff now, if you have like somebody driving a little cyberpunk car and you got stuff on the road in front of them and you got a heads-up display right here. I never thought before about that focus problem that you're talking about, but it's totally true. Like the cars or the stuff, your neon cyber goth city or whatever is in the distance, and your like labels are up here. You're not going to be able to focus on both of those at the same time. Huh.
Yeah, what's actually really interesting about the heads-up display things is, I mean, there are vehicles now that have I mean, there are various levels of heads-up display, but at the very basic one, having the speed and basically your dashboard, but on the windscreen is one that has been implemented. And the way they've done it is to project it at 2 meters in front of you. Right. So 2 meters being infinity in an optical sense, or 2 to 6 meters, I guess. So they're doing it to make sure that you're still able to look at the road and read the thing at the same time. That's the main problem with the dashboard, actually, is that you're looking down at something that's close to you to monitor things that you want to see whilst you're still paying attention to all the other road users and things that are in front of you to make sure you're driving properly. But by looking down and in front, not only are you not looking at the road, but you also have to focus on something that's much closer and then focus back at something that's far away. But like, again, they've addressed that problem by putting
So they've solved this, and that's so cool. Okay.
Yeah.
Well, there's so much cool stuff that we've dug into. I'm going to bring it back in a second. But first up, we've got a few comments. We've got a Happy Diwali from Embedded Art.
Thank you, Embedded Art. Happy Diwali.
We've got James hoping that this is the future that we get. Fellow Adlands alumnus in the comments here.
Yes, yeah.
And,
hey, Colin.
Cool. And then finally, I'd love to bring it back to what we started out with, which is your 3D printed music videos. And I've got two questions for you there. So if someone were just starting out, what would you recommend to be the easiest way for them to do it? Actually, we didn't get into the software at all, so maybe I'll make it. Okay, I'll make it this whole in question. Okay, so what's the software you use, and would you recommend it to a beginner, and what are some tips that people could use to get started out with this kind of thing?
In order to make the time lapses?
Yeah.
Yeah. Okay. So,
or I mean, actually, I guess with a 3D printer, like, is it in the slicer that you tell the head to move out of the way? Is that part of Octoprint, or?
So it's a couple of things that have to come together, actually. So for example, the words, it depends on the print. For example, this particular print is a model. All the text and everything is modeled in the 3D modeling software. So I use SolidWorks because that's something that I've got used to working in the 3D industry. They also have a Maker edition now, so it is more accessible for people to pick up, which I think is like $99 a year, I think. So if you make less than $2,000 a year or something along those lines, you're entitled to the making it from the designs, I believe. You're entitled to get the Maker edition of the software, and I think that's great because SolidWorks is an industry standard, and to be able to learn and use that even before being employed by a company is super valuable. So I think it's a great way to get started. But there are alternatives like Fusion 360 and things like that, which are also free for makers that they could use. But yeah, personally, because I use it every day at work, it's just easy for me to stay on the same system. So I use SolidWorks for my modeling, and then I might put the text within the model. So I always model the text and the object either together and subtract them from each other, or separately. So for example, with this vector model, because the actual vector model that is there, the STL file for it, I don't have the because I work as a mechanical engineer, I don't know software like Blender so well. So in order to do the things that I'm sure other people can do very easy, very well, that I just don't have the experience with, is to cut out the text from the object. It will take me a lot longer to do that. So I know Prusa slicer. That is the slicer that I use with my Prusa. So I can do this subtraction within Prusa slicer, because you can use the text as a negative body, and if you just model the text as a full solid body as it is, and model the head, or I had the head as a reference so it would all fit inside, and built it within. So I had it as a sort of semi-transparent thing within SolidWorks. I built all the text up within it, and then I exported the text as a separate model, and then I cut it out of Prusa Slicer once I was in Prusa Slicer. So that's how I actually got the text to come through the model.
Nice.
And then it's as simple as, because Octoprint is integrated into Prusa Slicer as well, clicking print. But when you go to Octolapse or Octoprint and go to set it up, there are some scripts that you have to set up if you want to use something like a DSLR, because it needs to talk to the DSLR in order to take the image. So you have to write these scripts, but all the code is online. So I'm not going to pretend like I did it from scratch. I really didn't. I copied everything that was there. I had to play around with a few parameters, but essentially you send using or going through the Raspberry Pi. I think I was using I forget what it's called, the protocol that you can talk to your Raspberry Pi remotely. I was then telling it or putting in the commands, testing it to make sure it could talk to the camera. And there's a snapshot command, and there is a command to save it to the SD card in the camera. As long as you put all of those in into your base script, you add that script into Octolapse. So when you're setting up Octolapse, there's a web interface that you can access, the Octoprint interface. Within that, there's Octolapse, and within Octolapse, you can then upload the script file. And so that means that every layer, it will run that script, and all that script is doing is taking the photo. Yeah, and once that's set up, again, I did this once a long time ago. Once it was set up, and the guide is all there. Like, don't listen to what I'm saying. Listen to that. There, the smart triggers, all of that brilliant stuff. It's all written out in an easy way to follow on this webpage. So I would definitely recommend going through it. And like you can see there, you just set up what printer you're using. Well, of course, is already there because it's that Octolapse or Octoprint setup. Then what camera instance you want to use, because you may have multiple cameras. You could have a webcam as well. I think you can run multiple cameras at the same time as well if you did it. So that's potentially something I might do in the future, but I don't really have DSLRs lying around to do that, because it would be nice to cut between different angles.
Right. And Oren asked what camera. You said you use a Canon DSLR?
Yeah, so actually I have two Canon DSLRs that I use. One, I do a lot of wildlife photography and other photography things outside of all of this. But that's what I normally use. Actually, the camera that the Canon 6D Mark II is the one that I'm using right now for this interview, which is the one which I do the wildlife photography and stuff for, which is the one that replaced my Canon 60D, so 60D. That's the first DSLR that I bought. Just it was very, very old at the time, used, but I wanted to make sure that I didn't want to invest too much into photography. I was learning photography at the time, again, to do like wildlife photography and other things like that, and I didn't want to sink too much money in. And I bought it for, I think, £150.
Oh,
Used. It was in quite bad condition, actually, but I bought some lenses with it. I eventually I bought a lens with it. I realized that I quite enjoyed it. I bought more lenses, and then I decided to upgrade to a more modern camera because I wanted some of the newer features, which is a 60 Mark II, and that's what I'm currently using for other stuff. But actually, all of my time lapses, apart from the one with the time, which is the latest one that I
that one's
uploaded,
beautiful.
all of them are done on my 60D, which is a super old camera. It's just it's just amazing what they can do, actually. Like the difference in quality and shot that you get between very, very old cameras and very new cameras, at least in the ones that I've tried in the Canon range, isn't huge if the lighting is very good, because obviously low light performance has got a lot better more recently. But if your lighting is good, and you can even adjust for the lighting by putting a much longer shutter time or something like that to reduce the ISO, so you get very clean images. If that's all set up and done properly, then you can use a very cheap, very old DSLR to do a lot of this work, as well as being able to communicate. There's a ton of cameras that work with Octolabs and G-Photo, but there's a whole list of compatible cameras, and as long as you pick, I guess, one of those, I think you should be good to go.
And you mentioned lighting and making sure that you have enough light. People couldn't see actually that you mentioned earlier that you print it in gray, and people think that you're printing with like multicolored filament or whatever. You actually show your lighting setup here, and you've got two different versions of this running up that hill one. You've got this green and orange one, which is beautiful, and this other purple and orange one. And so yeah, you really can just sort of, so that's what you're using is the hue lights and stuff. Oh my gosh, there's so much more that we could dig into, but we're coming to the close. I mentioned in the description that we talk about your kinetic sculptures and this cloud storage pun. It's a really cool pun. Everyone should look at that video. This is a really beautiful sculpture that you made.
I was very, very proud of this one in particular. I was talking to some of the 3D printer creators on TikTok and in the chat. I think some of them said, they said they were disappointed because they posted rainbow prints for Pride, and they had a lot of unfortunately negative comments come through for people who don't support Pride. And for me, like I have very close friends and people part of the community that I wanted to show my support. And I was actually reading these messages whilst getting on a plane to visit a friend in Sweden, and I had a notepad with me, and I thought, I have this thing, I don't know what it is, on planes, because of the background noise of the engines or whatever it is, my brain suddenly, I overthink a lot of things, but my brain just sort of goes into a creative mode where I can really focus. I get in a good flow mode where I can just focus on one thing and hash it out. So I had decided at that point that I was going to do some kind of Pride print. I'd seen something. This one is very much so inspired by some work by a fantastic creator called JBV Creative. He comes up with a lot of kinetic sculptures, a lot of kinetic 3D prints. I'd recently seen one of his where he did like a stop motion, like one of those flick books that you get and you see the animation. It was along those lines, and it gave me the idea that I could create a message that is within my print, that when you spin it and when you look at it in the right circumstance, something that doesn't make sense to you at the moment, when everything lines up and when you think about it clearly, suddenly makes sense. And it was that idea that the people who haven't spoken maybe to other people who are in the LGBTQ community, like if they had just had the right perspective, if they had spoken to somebody, if they'd realized that like these are just other people that they feel a certain way and they love whoever they love. So for me, it was, when you look at it, love is love. It doesn't matter. But maybe for some people, they need to look at it in the right light, in the right circumstance. And that was the message of that print. And that was that was one for me that was important anyway.
Oh, that's gorgeous. And I'm playing these videos, by the way, everyone. Obviously, a lot of these are music videos, and we don't have an amazing audio setup here for getting that through. Be sure to check out Prash's channel on TikTok and of course on all the other places that you are. We've got the Twitter link down below. Um what would be, I know that it's not necessarily all in the tech, but if you had, unlimited budget to grab one more thing to like upgrade your setup, what would be the next thing that you would change?
For my particular 3D printing time-lapse setup, a robot.
Ooh!
Because I want to be able to automate during the time lapse the position of the camera, potentially multiple cameras. So if I was really going for it, it would be multiple sliders and or robots, ideally a robot, because then I can pick whatever position I want, such that the camera will follow a path, a trace, and I can put things in the print in different places such that when the camera moves around, you see a different perspective of that print during the time lapse as it goes through it. That would be my unlimited budget setup. But I think a robotic arm with a camera attached to it, and maybe some nice lenses and things like that, it's not insignificant in cost. But yeah, that would be pretty cool.
Awesome. Thank you so much for answering all of my questions. And my favorite part is when we get to really delve into all the different stuff that you do. And you had so much to say about like fascinating stuff in VR and AR and biomedical tech and ethics. And I'm gonna have to update the description with all that extra stuff that we talked about. It's wonderful. Thank you so much for joining us. Everyone, be sure to follow Prash on Twitter, TikTok, of course. Thank you for joining us in the comments. And yeah, thank you again so much, Prash, for joining us.
No, thank you so much for the time. It's been a lovely chat. I've really enjoyed it. And we should definitely talk about more biomedical stuff on Twitter or wherever.
Oh my gosh, yes. Absolutely. Okay. Thank you, everyone. Have a great
Thanks.
one and hack on.